Well, next I'll transition us to our third presenter of the session. Our next speaker is Dr. Zhenlong Li from Penn State University. Dr. Zhenlong Li is an associate professor in the Department of Geography at the Penn State University, where he leads the Geoinformation and Big Data Research Lab. I'll turn over things to Zhenlong Li.
Thank you, Tara, for the introduction. And thank you, everyone, for joining the session here. So today I'm going to talk about the topic. I feel pretty excited about that is autonomous GIS, the next generation AI-powered GIS. So this is a project that my lab has been working on since 2023, over the last 3 years. Oh, next slide, please. So before that, I want to acknowledge my lab members and also the funding agencies here. And so my lab, Geoinformation and Big Data Research at Penn State, we are doing research about geospatial big data, spatial analysis, modeling, computing, and also geospatial artificial intelligence, which is part of the topic that we're going to talk about today. So currently have 5 outstanding graduate students, working on relevant projects. And the goal of this lab is to address a broad range of geographic questions about natural hazard, public health, transportation, environmental, or climate change. So next, please. So before we get into the autonomous GIS, I want to just briefly introduce artificial intelligence in general in GIS. So we have heard many terms like geospatial AI, or using AI in GIS. From my perspective, the usage in GIS here, in the AI usage in GIS can be classified into 3 categories. So the first one is using AI as information extractors. For example, we can extract flood water depths from these flood photos, and extract sidewalk, the slope or the width from these street view images, and also extract the suicide tweets or flooding related tweets and this on-topic tweets that from those massive like billions of social media posts here. Next, please. The second category is using AI for spatial models, for spatial modeling. For example, we can build a air quality prediction model using AI that can, works better and faster maybe than traditional models. And also for weather forecasting, wildfire risk modeling, we have some research done in this area. And the next, please. Yeah, so those 2 categories you can think of as more as like traditional geospatial AI research and applications. They are focusing on machine learning, deep learning, and those, using deep learning model to extract information. Using deep learning, we can build neural network as a geospatial model here for prediction or simulation, for example. Next, please. So the generative AI, as populated by the ChatGPT in late 2022, brings unique opportunities for GIS science. Please, next, please. So the third category that comes into the third category is AI as geospatial or GIS agents here. You can think about it, we can build AI agent for geospatial data discovery, for spatial analysis and spatial modeling, and for cartography and visualization. Next, please. So those are the building blocks of the autonomous GIS, or you can also refer to the agentic GIS or autonomous geospatial systems. Next, please. So what is autonomous GIS? I'm not sure how many people in the audience here ever heard this term, but we came up published this paper in early 2023, just after several months the ChatGPT was released. And we defined autonomous GIS as AI-powered GIS that leverage generative AI or like large language model general abilities in natural language understanding, reasoning, and coding to address spatial problems with automatic spatial data collection, analysis, and visualization. So this is a definition we feel that is just to speak of conceptually what is autonomous GIS, what it can do, and how it works in this way. So this paper here I'm showing here is a paper that we published in that year, and it's become, I think, one of the most cited paper. also the earliest paper that explored the integration of generative AI in the spatial analysis. So next, please. So there are some key visions about Augmented GIS, again, from the conceptual level. So we think that Augmented GIS is an emerging paradigm of integrating AI with GIS. So where the GIS not just another tool, but it become a geospatial analyst or a digital analyst here. It knows how to use GIS tools and with what data to solve spatial problems. For example, next please. It can use existing tools like the existing. We have over the last many years we have developed many GIS tools in toolbox, right? Like think about toolbox in QGIS, in ArcGIS, and they can use the existing tools and they can develop new tools like using the APIs, using the very extensive Python libraries, spatial libraries like GeoPandas, and many others, and also to use existing or developing new geospatial models. So in that case, like the geospatial like deep learning model can also be served as a tool here to be used by Augmented GIS in solving geospatial problem. Next, please. So the goal here is to make spatial analysis and geospatial technologies more broadly available to the wider audience here. And so we expect that through the Augmented GIS, since it's automation, automation also promote innovation, right? So we hope that Augmented GIS can promote innovation in geospatial research, GIS science, through large-scale automation. For example, through the Augmented GIS modeling. There's one example I'm going to show you later in this presentation. Next, please. So how to achieve this? Next, please. It should be designed as a programming and data-centric framework that we think that automate coding. We still want to use coding to address geospatial problems. So the key here is to use that to plan, implement, and execute the geoprocessing workflow. I will have more about this later. And it also should be implemented into a diverse Augmented GIS agent that can work individually or collaboratively. So I'm going to show you later again some examples. Next, please. So, so a key capability of Augmented GIS is its ability to self-learn and self-improve, which is learn from the document, for example, domain knowledge, learn from experiences like the past task, the interaction with human, and the field, operations, and that's the experience, and learn from the simulations. So those are the self-learn goal that we think is very important for the Augmented GIS to grow by itself. Next, please. So the rationale behind this concept here, at the very beginning, we think about what we can do with generative AI in the geospatial analysis. And then we think very hard. Finally, we come up with a solution is from the core of the GIS or spatial analysis. So spatial analysis, think about it, is essentially a geoprocessing workflow, right? It's the data flow, it's operation flow, and we have data input, some using some tool to process data and get some output. Output become the input for another tool. Finally, we get the final output. So it's a geoprocessing workflow. Example I'm showing here that is a workflow built with ArcGIS model builder for the typical site selection problem in GIS. And though typically this workflow is built manually by human. Next, please. So Augmented GIS here is going to use AI as a reasoning or decision core to plan, to implement, and finally to run this geoprocessing workflow. So if we have a specific problem, we are able to autonomously to generate a workflow, to generate the code, finally to run this workflow, and then we're able to solve this problem in an autonomous way. Of course, humans still here to provide guidance, provide boundaries, and to get final result here. Next, please. So this is the prototype that we developed in early 2023, 3 years ago. So what we have here is that you take a question from the user, and then it will convert to the workflow, geoprocessing workflow. And then for each workflow here, there are operation nodes, think about tools. It will build this operation using Python code. And finally, it will combine all this operation together, following the workflow, and to have a final program to run together result here. Next, please. So I have a quick, case study here. It's not a video demo, but it's just a case study to show that how it works here. So for example, in this system, you can just input the task here, which is a request, right? Or the question, like show the monthly change rate of population mobility for each region in a France map. And then we have also asked it to draw a line chart to show the monthly change rate for each region here. And then have some other requirement, and also the data location, we tell it what data are there. So next, please. And then the strike-through information is not needed right now. And this is, remember, this is already early version, but now we have a data understanding module autonomously understanding the data. So we don't need this strike-through information here. Next, please. So this is the result that directly get it from this workflow. From this question here, you can see we have the workflow generated on the left side, and then we have the code generated on the right side, and then the result, the map I'm asked, we requested also the line chart we requested here. So those are the example, one of the case study actually in the paper I mentioned before. If you're interested, take a look at that. You can take a look at that paper. Next, please. So we have this project called AMGeo. It's open source. That paper also I co-author with my former student, Huan Ying now. He graduated as a postdoc working at Emory University. The project now is open source, and anyone, you are welcome to test and explore that, to run that on your own machines, and then also contribute to the project here. I have a link here for you to use. Next, please. So in that paper, very early paper, we envisioned two forms of autonomous GIS. The first form, the one is the standalone version. That's like you have website, for example, you have everything within. You don't use third-party like GIS software. And then the second form here, then the other form here, the GIS Copilot style, which is we have traditional GIS software like the ArcGIS or QGIS, and then we can have a chat box along with the software traditional, and then you provide a kind of a new user interface as using natural language to interact with the system. And then still the system will be able to automatically build the workflow and then perform the task for you instead you manually click the button. Next, please. So I'm going to show you two of that quickly. The first one is a GIS Copilot. Since we implement this, in a QGIS because it's open source GIS software, right? So this is led by my PhD student Tammy Toppy here. And we have a paper published called the GIS Copilot towards an autonomous GIS agent for spatial analysis. Basically, this agent here is going to use the built-in software or toolbox provided by by QGIS, including GDL or other very common libraries. And then also it has capability to use external geospatial library like the GeoPandas or and others. So and then it can take the natural language as interface and input like questions, and then perform the vector analysis, raster analysis, and common geospatial analysis here in an autonomous way. So next, please. So I have a quick video here to show you how the Copilot works here. All right, please click the video. Yeah. All right, can you pause a few seconds, please? Yeah, this is a task, we directly going to put into the Copilot here, like create a bus stops accessibility index for the Philadelphia area. All right, next, please. Yeah, can you play the video? Yeah. So we have a number of steps. Basically, we can do this, have a student work on that, or I can work on that manually by using the data here that's provided here. But the system using the Copilot here, this is the QGIS interface. On the right side, you can see the Copilot interface. You just need to type the question here and then click Submit Send Request. Click Send Request. And then it will start to analyze your request, and then try to understand the data, and then generate a plan, a spatial analysis plan that will be showing here step by step, analyzing the task here. So in this example, we are using the GPT-5. So since it's a reasoning model, it takes a little bit while to reason. So this is a task breakdown, which is based on the problem. That's a task that the AI is going to work on. Now this is the data attribute information extracted from the data, so he understands what data provided here to answer this question. And also, these are the tools that's selected by the AI that, okay, to solve this problem, what kind of tool they should use. Also, for each tool, you can click that and to see the tool, documentation there. So each tool you can think about is a skill or there are tool code that can be used by the agent here. So all the tools that in the QGIS had been built in here, which is the AI are able to use all the tools in the toolbox to solve the spatial problem. So now it is creating the geoprocessing workflow, which is the planning stage, which is a very important stage, right? When we work on spatial problem, we think about what's the steps, how to solve that. So that's the planning stage here. Yeah, it's generated here. All right, this is the planning, this is the workflow. And then next that it will generate the operation code or generates the actual Python code using the QGIS Python, PyQGIS. Oh, can you now please go to the next slide, please, since we don't have time to show off the video. Yeah, so I have some screenshot. Next, please. You see this AI generating the operation code now. Next, please. And then this is the result finally produced within several minutes. This is the result overlapping with overlaying the bus stops also. Next, please. And this is the final thematic map that generated for showing the accessibility index based on the requirement. So all this done without any interaction with the system. Next, please. So this system is also tool is open source, and we receive a lot of interest for this one. It has over 18,000 downloads already since first release. So if you want to learn more, we encourage you to try the system out by using the first link here. It has a get started, very detailed documentation to show you how you get started. You can also get a free key to use to test that. And also we have over 100 test cases here, again, using this link, please. Please, next, please. So the other one is I want to quickly show you since due to time is to so it's a standalone autonomous GIS here. In this way, in this system, which is also led by Temtopi, now we are still working on that, but this is a very early version. I want to show you its capabilities. So this is not relying on any third party like QGIS or ArcGIS. It's all using the open source Python spatial libraries here. And then it goes beyond. It goes beyond just like perform spatial analysis. It can perform, you ask spatial questions, and then it can perform generate a hypothesis, perform spatial statistics, spatial analysis, and produce a result. Finally, to write a draft manuscript for you. Okay, can you play the video, please? Yeah, I think we have. So now let's see. I'm going to have one question here. Just quickly show you the question. Okay, can you pause a few minutes, a few seconds? So this is a question. Oh, no, can you go back to the video? I'm sorry. I want to show the question to the user, to the audience here. Yeah, just show the question, please. Need to play that. Click the play button. Yeah, yeah, and just pause a little bit once we have the question here. Oh, okay. I don't know what's happened. Oh yeah. So this is a question that this if you can forward a little bit, that's the question on the screen, not this one. Yeah, this question, please. Yeah, how does the proximity of two hazard waste facilities influence the spatial patterns of adults' asthma prevalence? This is a spatial question we directly ask it. And this is like, think about you need to have generate some hypothesis, right? Generate some goals, objectives. And on the left side, you can see we put our data here. Okay, next, please. You will see, okay. All
Dr.
right.
Lee, I want to make sure
Yeah.
too that we have a chance to ask you at least one
Okay. Yeah.
question in
I'm
the
going to
Q&A.
Yeah, yeah, that's you can just put next slides, please. Yeah, I don't think we have time to show the video.
Yeah, because I do know that
Okay.
you had like some additional resources on the
Right,
geospatial
right.
AI community, but
Yeah,
I
yeah,
do
yeah.
know
Okay.
we do have one question in the chat. So if you're okay,
Okay.
I'll help you move to like
Yeah.
responding to that. So
Yeah.
the question's about how do you see the teaching of GIS slash Geo AI evolving so that years from now, GIS professionals still have the geospatial analysis skills to serve as a human in the loop. Human in a loop if analysis skills are increasingly performed by autonomous GIS agents.
Yeah. So I think, if I'm not sure you are able to move to the next slides. The last slide here, we have some, I have one slide showing some questions that we already discussed, the last slides, last one maybe, if that's possible. So, oh, that's a lot of slides there. But anyway, I can answer the question here, which is we see um, definitely there's a challenge here, not challenge, a change that we need to see about the how we teach the GIS courses and how students want to learn this because the very basic like entry level spatial analysis. I mean, if you're looking forward here in next several years, it it is will be able to be done in a way by the AI agent here. So that's something that's a trend there. So that's why when we think about how when we learn the GIS, the software, so clicking like learning how to use the software it should be different compared to before because now I think more importantly to think about we can ask the questions, we can probably collaborate with the AI agent here to solve the problem in a more innovative and efficient way. Because just the coding here, AI can help us do the coding. The workflow here can also generate workflow, but many times when you have a spatial problem here, and then I think still the human input here still play a key role here to guide the AI to solve this problem, to define the boundaries, and to make it work for us. So that's my quick response here.
Well, thank you, Dr. Lee. You definitely
Yeah,
had us staying at the forefront of the AI in your presentation. And I do know that we do need to move on right
yeah. All
to
right.
the next presentation set. But I do want to thank all the presenters in this morning's sessions, and we really appreciate your time and your sharing of your expertise this morning. Thank you.